Hi everyone, myself and Arun Kumar from SNS College of Technology in the Department of EC. In this video, we are going to see about block diagram reduction techniques. So generally, the block diagram reduction technique has been used for control system to reduce the number of blocks. For example, if you want to access multiple number of data at the same time means we are using this block diagram reduction techniques in linear control systems. So these are all the slides we are going to see in this video. Introduction, block diagram reduction, rules, activity and followed by assessments. Understanding the reduction techniques, it comes under introduction. So these are all the blocks. So they are combined with each other as a multiple number of units. So here the function is to reduce the number of input units so that we can able to access or communicate to the neighboring devices with a small number of control elements. So let me see how these elements has been reduced with the help of block diagram reduction rules. So these are the rules we have been formed based on the block diagram reduction techniques. First rule is if the blocks is in series, suppose for example the blocks is in series manner, see G1 of S into G2 of S, then automatically it comes under G1S, G2S, multiplication has been done. And if the block is in parallel connection, then addition has been done, because if the G1 of S and G2 of S is has been added by plus symbol, so G1 of S plus G2 of S, like this this two combination has been formed based on the reduction rules. Next one is moving a summing point. So here the summing point means if you want to add a multiple number of elements, or if you want to remove the elements, so that we are using summing point. So here the summing point is plus symbol. Input 1 and input 2 is given to the controller G of S. So here the summing point is moving towards the next block means then how it is done. So here we can see that input 1 also same. If the plus is move next of the block G of S, so that it can move to the G of S also, then the G of S also given to the input to the system. So the same process will be executed for this moving of the summing point system. And next one is interchanging summing points. So while coming to the interchanging of summing points, we need to consider the block and consider of the output and input of the systems. So here they given about the examples, plus and plus is both the input and output has been done with the help of the controller GFS. Then after interchanging, what will be happen means the corresponding GFS is moved towards the next of the block, so that the formula has been changed as 1 by GFS. So this is the rules of the interchanging of summing points. And next one is block diagram reduction rules for the taking point. For example, if the branch point is moving towards the next block means, then automatically the transfer function g of s has been forwarded to the next of the block. Then the formula has been added. 1 by g of s is to be added in the next block of the system. While connecting to the block of this corresponding controller unit, we need to add 1 by g of s of the system to the next block. And next one is the important rules is feedback elimination system, because the feedback is the system which is having input system, controller and actuator, and moreover we need to consider the feedback of the corresponding loop by summer of the system. So here the summer is plus. So we are going to eliminate this these type of blocks by using this feedback loop elimination system. So after solving this, we are getting g of s divided by 1 plus g of s into h of s. So it will be implemented based on the plus and minus of the summer, because if we are having any plus system in the error means we are using minus. If it is not, if it is minus, then we are using plus. Next one is the main rules of the parallel path with the feedback means. Suppose if we are having two parallel blocks while connecting with the loop means, we need to eliminate the system by using a feedback loop. We need to consider the parallel block rules. After that we can fix the final element by using a feedback loop. Mind mapping. So here we are using a lot of additional systems based on this mind mapping technique. For example, feedback loop has been formed based on the canonical form or transfer function g divided by 1 plus gh. And next one is moving summing point means ahead of the block or before of the block. So based on the number of rules and regulations, it has been changed. Activity. So here the activity is given as GD group discussion, and the task is as a team of autonomous engineers discuss the recommend which system should use open loop control and which system should use the closed loop control. Justify your decisions based on the cost, accuracy, safety, and performance. Assessment. First one is cruise control used in model vehicles like Tesla or WAS is an example of open loop system, closed loop system, manual system, feed forward system. The answer is closed loop system because the cruise control is based on the feedback based mechanism, so that we are using here as more closed loop system. And next one is which control system is commonly used in automatic traffic light timers in small towns due to low cost. First one is closed loop system, feedback control system, open loop system, and adaptive control system. It is comes under open loop system because it is free of control. We don't have any control here. Once if you are giving the corresponding inputs to the system, means it will be indicate automatically to the control of the unit. So these are all the reference I have taken for this video. Thank you.